either one of you bumped into the fact that Blackboard looks different this term? You haven't looked at it. Okay. They've gone from the old Blackboard to a new Blackboard they call Blackboard Ultra. This was the icon for the old Blackboard. This is the icon for Blackboard Ultra, which by one student said, there's a few things that seems like it's easier to navigate, and I would grant that's probably true. But what I've heard this week, and the more I hear, the more I think it's true, they're using us as beta testing for it because there are some glitches in it, and some things it's just not doing very well and doing awfully slowly, but it's doing. So anyway, let's go on and start. I don't usually teach from Blackboard, but I was going to do it this time just so you could see the differences in this new Blackboard. I don't know what this is doing, but I'm going to try to get it out of the way. Okay. Now, I don't know if you see this. This may only be an instructor side. What you would see is something more like this, I think. But again, this is an instructor view of it. And let's go down to our course. Here we are. I'll click on that. This is the new way that this looks. Before we had tabs over here, and you had to remember what tab. This just shows everything here. Not quite everything, but everything you go from is here. So this is it. So whereas before you had a tab over here that said maybe something like course and book information or something like that, you had to know that's where the syllabus was. For my course, maybe someone else had it in a different tab. I don't know. But this way, you see it, and there it is. There's the syllabus. And so I'm going to click on it first. Now, what it used to be, if you clicked on this, it would open the syllabus. Now it goes to this, and I've tried to click on this, and nothing happens. Now, I don't know what it does on the student side. I would hope that would open the syllabus for you. But what I have to do from my side, and I would hope they don't have this on the student side, because this allows you to edit it or delete it. And hopefully you can't do that. So what I have to do is download it. But hopefully you have a different way of doing it. Okay? Now I have to wait, and there it is. So now I open it. And it's so slow. I wish I were doing this from flash drives. That would be much quicker. But I wanted to show you this so you at least have a clue on how to navigate this stuff. And this takes forever. The first two classes, these are not big files. There's no reason for this to take this long, and yet it just sits here and sits here and sits here. At some point it freezes. Maybe right there it froze, and then I can do something to jog it to move. So I'm going to try that now. This is what I've had to do every thing. Control-Alt-Delete and do Task Manager, and then it opens. Why you have to do this, I don't know. It's just kind of crazy. Okay. Now you shouldn't be able to edit my syllabus, so hopefully you don't see that. And okay. So here's the syllabus. Looks like most other syllabi. This is Math 237 linear algebra. That's what y'all wanted, right? Okay. Blackboard, blah, blah, blah. And the meeting days and times for 11:30 to 12:45, Tuesday and Thursday, Best Mechanic 255, all this. All this is the same. Let me remind you, my voicemail is very sporadic. So I would never suggest you leave a voicemail message. I may not ever hear it, or it could get lost in the sauce. So if you call, only call during office hours, and if you don't catch me, hang up and call back a little later during office hours. Or email. Now right now I'm way behind on emails too, but I'll eventually hopefully catch those up. This is my office. You know where it is, both of you, right? Okay. That's my phone number on the Bessemer campus. I'm basically here Monday through Thursday. I'm on the Birmingham campus on Friday mornings. That's the office there. Now, don't leave me a voicemail there either. That's not even my phone. Okay, I'm in the office of the grant coordinator, and that's her voicemail. So I can answer the phone there, but I can't receive any voicemails there. So don't leave a voicemail on that number either. I'll never get that one guaranteed. This is Dr. Pruitt's office. I'm in the copy room behind the secretary's desk. Okay. Here are my office hours so far, as I know them. On Mondays, I did have a Math 100 class, but I gave it to somebody else, so I'm free from 8 to 10 on Mondays. And then I have Calculus 1 at 10 o'clock. I have Calculus 3 at 12:30 or sometime like that. And then I have differential equations at 2:30, okay? So from 3:45 until 6, I'm in my office. So 8 to 10, 3:45 to 6. Tuesdays and Thursdays, they're the same, okay? This time is different. I'm going to have to change that. When I put this in, I was under the impression my trig class wasn't going to make. Then I found out it did make. So now my office hours on Tuesday and Thursday are 8 to 8:30 in the morning. It's only a half hour. And then after this class, which is 12:45 until 1:15. So this should read 12:45 until 1:15. Okay, that's Tuesday and Thursday. Now that's not many office hours on Tuesday and Thursday, and here's why. I have Math 112, 8:30 in the morning, 113 at 10 o'clock, this class at 11:30, and then Physical Science, first 111 and then 112, depending on the mini-term, at 1:15, and those are mini-term classes with labs, so they go from 1:15 to 5:45. So no office hours to speak of, Tuesday or Thursday. Now Wednesday starts out a lot like Monday, 8 to 10. However, and I'll show you later, I can't have this last set of office hours there because I have a physics class on the Birmingham East Campus in the evenings. So I don't have that, 3:45 to 6. Okay? So the next best block of time is 11:45. That's after my Cal 1 class and before my Cal 3 class. So I have 45 minutes there. Usually I'm eating lunch, but I eat lunch in my office. I bring my lunch so you can come and see me there. Okay. I already covered Tuesday and Thursday. Friday, I'm on the Birmingham campus most Fridays, 8 to 12. And all those are office hours. However, they love having meetings on Friday, so I may not be in the office the entire 4 hours. All right, let's get to the course description. This course introduces the basic theory of linear equations and matrices. Now, basically, you're fairly familiar with linear equations, right? So we're going to introduce matrices. Real vector spaces, basis and dimension, hopefully we'll get that far. Linear transformations, so far I haven't gotten that far. And matrices, we'll do the matrix part. Determinants, we do that. Eigenvalues and eigenvectors, hopefully we'll get that far, so far we haven't. Inner product spaces, I've gotten there a couple of times, and the diagonalization of symmetric matrices, which is a fairly straightforward thing. Additional topics may include quadratic forms and the use of matrix methods to solve systems of linear differential equations. Not going to get there, I can almost guarantee. Okay? So there's your basic course description. We'll get as far as we can. With a small class like this, with such sharp students like we've got here, we'll be able to move along a little faster than most terms. Prerequisite is Math 126, which both of you have had. Co-requisites are none. The textbook is this one. Okay? Elementary linear algebra. And this says 7th edition. Mine is 7th edition. Do y'all have 7th or 8th? Yeah, okay. I don't know if I typed that wrong or if they've increased. I think they may have come up with a new edition. I thought this was a new edition, but we'll see. The author you may recognize. Ron Larson was who we used for pre-calculus, algebra, and trig, and calculus 1, 2, and 3. Okay, he's a pretty good author. Okay, that's not why I chose the book. The reason I chose the book, and we'll get to this in a little bit, is that course description. It's chapter by chapter what he presents in here. Every other linear algebra book would be here and here and here and here. This one, it fits it like a glove. I don't know how he got it that good. But also, he has all these other things, such as, well, no, this book doesn't have it. I like him because he has all the other resources. This book, he doesn't have them yet. Maybe the 8th edition he will. We'll see if we get that. Okay, because this is the 2017 text, which means it's about, no, okay. The 7th edition was 2017, I'm almost guaranteed. I'm way behind. The 7th edition is 2013, so there is an 8th edition. I don't know why I don't have the proper one, but I'll get it. Okay. So far, in fact, I've been teaching from it for a couple of years now, and this is the first time I've realized that there's any difference at all. So there's not much difference. Okay. Y'all know about Cengage Unlimited? Okay. This is one of those books, and you can do it. All your books. I'm sure this book, if you bought it off the shelf, is going to be more than $119. Cengage Unlimited, you get all your books for $119, all the Cengage books. So I won't go into this if y'all are comfortable with it, right? Please bring, and if you got a graphing calculator, that'll help speed you along on some of the matrix operations. It's not necessary. We'll do them all without it, but it will speed you along if you know how to use it. Paper, pencils, of course, you know to bring that. Here's all the advertisement stuff for Cengage Unlimited, which I think is inappropriate to have in the syllabus, but they put it in here anyway. Okay, here are the other courses that do offer Cengage books, so all these you get for that same $119. Okay, there's various packages you can get, so I'll let you see that. Don't throw away your receipt. Now we're finally back to the syllabus again. And I think you've heard me talk about Blackboard before, right? There is a new Blackboard now. I still don't like the way they phrase this, but we can live with it, right? Here are your competencies and objectives. So let's, student learning outcomes. Students will solve systems of equations, of linear equations and matrices. Now, remember we're talking systems of linear equations. Now, back when you did this, probably in high school or wherever you did it, you probably had 2 equations, 2 unknowns. You may have gotten up to 3 equations with 3 unknowns, but you probably didn't get any higher than that, because those get really difficult to do. Matrices allow you to do that with a very organized fashion. Okay. So, students will solve systems of linear equations, big systems, small systems too, linear equations and matrices. Students will apply the properties of determinants to the solution of matrices, and remember determinants are one of the things in the course description. They'll work with vector spaces, identifying the basis and dimensions. Those 2 different topics are all in one chapter here. We'll work with inner product spaces, that's the next chapter. We'll perform linear transformations. So far I haven't gotten this far, but hopefully we will. Work with eigenvalues, eigenvectors, and diagonalize symmetric matrices, and we'll, guess what? Research and write on a topic in linear algebra. Okay, you can't get away from that, can you? All right, now here's what I was saying about why we use the course. Okay, if you look at this, systems of linear equations, that's chapter 1. Matrices, that's chapter 2. Determinants, that's chapter 3. Vector spaces, which includes basis and dimensions, that's chapter 4. Flip a page. Inner product spaces, that's chapter 5. Linear transformations, that's chapter 6. Eigenvalues and eigenfunctions, which includes diagonalization, That's chapter 7, and that basically is every key word that they had in the topic. I could not find a book that went down and covered just what we needed without a lot extra. So that's how we wound up with this book. Washington's a good author, but so far he doesn't have as much supplementary material for this text as he does the other. Maybe chapter 8 he will. Edition 8 he will. So anyway, chapter 1, very short chapter. Let's do that and have a test. Now I have to get from you. Do you prefer a take-home test or in-class test? One shot. Okay. So when we finish chapter 1, I'll give you a test. Chapter 2, give you a test. So just like probably we did with trig, right? And calculus. Okay. So that's why there's a research paper. There probably will not be a comprehensive final exam. It's just going to be the last chapter test. We may not get to chapter 6 or 7, but whichever the last chapter we do, that'll be your last test. That'll be the thing. So how do I compute your grades? It's pretty straightforward. The research paper is required. We'll count as a test grade that cannot be dropped. The test will be given at the end of each unit of study. Those are basically chapters. The lowest unit test may be dropped. The average of the paper and the remaining chapter tests will be your grade. That's pretty much like before. The last test, whatever the last chapter we cover, that one can't be dropped because everything pretty much in math builds on itself. So in order to get the full weight of the course, you need, that shows up in the lesson. So the last test, basically your final exam, whatever that last test is, won't be dropped. And then you are familiar with this, A, B's, and C's, go there, don't go down here at all. Okay? I think I told you about how they misworded that, so you don't need to worry about it. Try to be here every day. I know that life gets in the way sometimes, but even though I record all the classes, you can't ask the recording a question. So be here. That's where we'll be practicing doing everything that we do. And I'll tell you this too. This book has no PowerPoint. It has, so I'll be doing everything on the screen. Okay? So it really helps to be here. You know about withdrawal. It's way better to withdraw than it is to get a D or an F. Okay? So if you have any questions on that, I'll be glad to make them. Don't know how you do makeup work with all the tests and take-homes, but the key is try to get the test in, if possible, within a week. That's what the goal is. But if you need longer, okay, but just try to get test 3 in before I give you test 4, and that kind of stuff. You don't want to get way behind because then you get no feedback from the earlier test to know whether you're doing things right or wrong. Now, I've had some people that delay until the end, and then they miss the same thing on several tests. If they had just gotten the test in on time, they would have not made that error repeatedly. Okay? So they lost compound interest on their losing points. Okay, makeup work, don't really know how, okay, we already talked about that. Lateness, I'm going to try to start on time, have a class right before here, so we've got, now, they've put this academic integrity in here. Let me just summarize. Don't plagiarize, don't cheat, okay? The odds are you are taking this course because you're going to need it somewhere in the future. Plagiarism, cheating, it's not going to help you be prepared for whenever you need it in the future. So don't go there, okay? Professional decorum. Oh, isn't this something important to have in the syllabus? A waste of time and space. Y'all have heard all this before. Please don't snore, okay? You got that one, okay? Don't get too outrageous in class. Don't be driving your four-wheelers around in the classroom, okay? If you need a snack or caffeine to keep you alert and going, I prefer you alert and going to out, okay? That relates to this one, okay? And as far as I know, every term y'all wore appropriate clothing. I don't care about those, but I tell you have hats all the time. But It's a C3D. Okay. Course concern. This is our concerns with you. This is your concerns with us. Okay. If you have any problems, you don't think I'm giving you a fair shake. I don't know why you're in my class again, but please come see me. We'll work it out. If that doesn't work, we'll go to the department chair. Oh, that's me. Okay, we'll work it out. Okay, if that doesn't work, we'll go to the associate dean. I'm in his office every Friday morning. You can chew me out there. Okay, we'll work it out there. The dean, vice president, the president, as far as it needs to take. Let's start at the lowest level possible. Okay. Any questions? Okay, you've seen this before. Okay, discrimination and harassment, you know about that. If you start harassing Dawson, no, I'm just kidding, okay. I count bullying too, but guess what? I don't see this. I never have seen it. I've been here 20 some odd years, okay. You may see stuff I won't see. Let us know. We don't want it happening, ever. So let us know. We want to deal with it. We'll deal with it fairly, appropriately, but we will deal with it. We don't want to have it. Okay, disabilities, we want everyone to have every opportunity to learn to the top of their ability. So if you hearing, vision, dyslexia, reading, whatever, if you have a disability, let us know. We'll try to accommodate any way we can. Okay? But you got to let us know. Okay? Any questions on that? All right. Now, sort of I'm going through this pretty quickly because I know you've heard it before. And I doubt if either one of you are planning to withdraw. But if either of you are on federal financial assistance, okay, that will pay for you to retake a class once, but not twice. Okay? Now, I can't imagine either one of you getting into a situation where you get so far behind you can't possibly pull out a passing grade. But if that were to happen, withdrawal is better than a D or an F. Okay? Because a D or an F is going to hurt your grade point average. I know you all have better than a 1.0 grade point average, right? Okay? So a D is going to hurt you, an F is definitely going to hurt you. A W does not hurt you. Okay? The only place a W can hurt is in, financial aid situation. But D and F hurts the same way. Okay? So do that. Now, why I said all that? The 60% completion date. If you withdraw before that date, you have to pay back any federal financial assistance. Okay? If you wait until after that date, you don't. Now, this date up here, they say last day to withdraw and receive a partial refund. That's withdrawing from school, not withdrawing from a class, withdrawing from school. If you enrolled for classes and then came up pregnant or something like that, just kidding, okay, and you thought, can't possibly finish, or you moved, or something like that. If you completely withdraw from classes before January the 31st, you get a partial refund. After January 31st, you don't. This one down here, this is withdrawing from a class, an individual class, or the whole thing too. And that 60% completion date is for that. Okay, spring break is coming up the end of March. Last day to withdraw. So basically, if you are going to withdraw between Friday the 13th of March and Monday the 28th of April. If you're on federal financial assistance. If you're not on federal financial assistance, it doesn't matter. The withdrawal is done. Okay. And neither one of you are graduating this term, or are you going to be able to do something like that? All right. I think we did discover a few places that I do have to make a couple of changes. The addition of the book and, something like that. Maybe not. Maybe that was all correct there. But possibly office hours. If I do make any, I'll let you know when I get them made. Then you can sign this form or email me the form. Any questions? Any questions on the syllabus at all? Okay. So that ends the syllabus. So that's how you find it on this new Ultra. Okay, and see, everything's listed here. Here's the locator card. If you recall how that looks, that just shows when I'm on campus, not on campus. And again, it used to be I could click on this and it would open. It won't open now for me. Maybe it will for you. I have to go over here to this, which you shouldn't be able to do, and download the original file. And these downloads take forever. That's why I don't like to do it. I wish I were using my flash drive, but I wanted you to see it on this new Blackboard Ultra. After a while, it sometimes stops, and then you have to jog it so it continues. I don't know why Microsoft products are so stinking awkward, but they are. Well, there it is. Okay. All right, again on this, a locator card. My name's there, my office phones, both in Bessemer campus and Birmingham campus, my email address, department, that kind of stuff. And here's basically my week, okay? All right, so Monday, I gave away my Math 100 class in the office from 8 till 10, and I got Calculus 1. I have 45 minutes for lunch, but I'm in my office, so that's my office hours there, 11:45 until 12:30, and then Cal 3 is then, and then in the office from 2:15 until, then right after this is differential equations, that goes to 3:45, and then I'm in the office from 3:45 until 6, most Mondays. Okay, Tuesdays and Thursdays, packed to the gills. Pre-calculus algebra 8:30, pre-calculus trig at 10, this class at 11:30, and then this is my little period of lunch, and office hours 12:45 until 1:15. Okay, 1:15. First mini-term, physical science 111, second mini-term 112, both starts at the same time, and the class, because it's mini-term, it's 2.5 hours class, 2 hours round both days, and so 5:45 through, and I'm usually off campus by 6, sometimes. Okay. Wednesday's a little different from Monday. It starts the same, 8 to 10 I'm free. Cal 1, lunch, Cal 2, Cal 3, differential equations. And y'all are both in Cal 3? So we'll be seeing you then. We'll see this again. Differential equations. But on Wednesday, I don't have this block of office hours from 3:45 to 6 because I have to, as soon as I get out of differential equations, I have to start packing my bags to head to Birmingham East Campus because I have a physics class starting there at 4:30 until 6:30. Okay? And I'm off campus sometime after 6:30, which is usually closer to 7. All right. And Thursday's the same as Tuesday, and Friday's on Birmingham campus. And I put a lunch in here because it requires to, but most of the time I don't eat lunch on Friday. I may have a snack or something, but I'm there. It says I'm off campus by 12. Don't bank on it. Most days I'm there as well. Most days I'm there before 8, but not too much before 8. Almost always well past 12. They just require us to put those end times in. All right, any questions on my schedule? Basically shows my office hours again. Okay, then we'll end that one. And go back to research paper instructions. And I should be able to click on that, but I haven't gotten it to work, so I have to come over here and download the original file. And you've seen this every class you've been in mine, so I won't go over in gory detail, but I'll answer any questions you have on it if I can get it to open. Okay. All right. Do you have any questions? You want to hear this again? Want me to go through it again? Anything you forgot about it? Only little differences are the bonus points, 4 points for the month of, if you turn in your paper in January, 3 in February, 2 in March. The first 3 weeks in April, you get 1 bonus point. That last week is also the first week of finals, so you don't. That week you don't. So it's only the first 3 weeks in April, you get 1 bonus point. And be sure you turn in a page from the source. Any questions? This makes it easy. Y'all have heard this many times before. And you'll hear it again on Monday, okay? Because we'll do it in that class as well. Okay, since this is a Cengage book, they do have these web-assigned class key. And here it is. Lawson.al 5304 space 9506. I think the spaces are important. The decimals important. If you are doing the ebook, I think you need that to access it. Okay. Now, the folks at WebAssign set up a course for you. I don't do WebAssign. It turns out to me to be more frustration than it's worth. There's plenty of good exercises in the book. However, they set up a course for it. You get all the course information, the tutorial help, all that kind of stuff. It's there. So you can use that to your heart's content. It's not required. I'm not going to grade you on it. You don't get extra points for it or anything else. It's just so you can have more means for exercising. So there's the class key you'll need to do it. Any questions? Okay. Now, next is the YouTube videos. You used to have to go different places for this. They just show up here. Now, I don't know if you've noticed it. Documents are given this symbol. This is a link. So you see the chain link there. Okay. So here are the YouTube videos. Now this one, I think, goes straight to the link. It always has before, but for today, it's really slow. But it looks like it's going there. All right. Now, you've been in my classes before. You know the most recent, and you notice here, no PowerPoints. It's all written out on the screen in the tablet PC. So that's what you're going to have to be reading. The oldest stuff is at the top, and the newest stuff is at the bottom. Okay. The last time I taught the course, we didn't get as far as 4.4. So this is from a previous time. We did. One time I taught it, we got 5.1. Maybe more than once, okay? But the last time I did, that was from there. But here is where last time I taught the course, we started right here. So these were all files that were left over. So I'll leave everything in here until we cover it anew. So after today's class, I will name today's class Math 237 Syllabus. I'll delete this one and put the new one on. But the new one will be at the bottom. So everything you see at the top is from previous terms. And the stuff that you see at the bottom, these are all the ones that we did last term. Okay. So that's how this is set up and how you can use it. So, any question on YouTube videos? None? Okay. Now, the next two are both Also web links, they're either things, I know I found this one, and I don't know if I found this or another student told me about this one. These are two other links that support this course. Now, the last time I checked, neither one of these were the most recent editions, but not that much changes between editions. So you can get to either one of those and maybe get extra stuff. Now, if you ever see anything out here that you have not visible to students, let me know. It's just that I forgot to. I put everything on here, I put visible to students. Now, some instructors keep some things hidden for a while. Say if they are going to put a test out here, they're only going to make that visible for a very short period of time. I don't put my test out here. So everything should be visible. So if you see something with an X through this, let me know. That means I just forgot to make it. It looks like everything's there. There's the syllabus. Any questions? I mean, there's Blackboard. Okay. Any questions on any of that? Okay. I'm going to get out of Blackboard. Actually, I'm not really. I'm going to leave it up for my next class because I'll be showing them the same thing. Okay. And y'all have heard all this before too, so speed me along as much as possible. Safety. What 3 areas of safety do we need to know about? So fire, weather, active shooter. Okay. You have questions about any one of those? Any at all? Okay. I'll just quickly hit the high points on this. In case of fire, we go out of the building and we meet down in that parking lot right there. Okay, the parking lot from here and up the hallway. That's where we meet. We gather together. I take my roll book, make sure everybody's accounted for. I think I can remember something pretty well. But if we can't find you, someone has to do that. Take the work or stuff like that. Whether you don't go out of the building, you go in. Below an interior, and we go down to the first floor, that floor that's along there, going to the library. Okay? The hallway is probably the best, safest place. But any of the interior rooms will be equally good. It's just that the hallway has emergency lighting. The interior rooms don't necessarily. So if we lose power in the hallway, it'll probably be better. Now, you might say, do we need to even think about inclement weather? Has anyone heard the reports for Saturday? Yes, we are. Believe it or not, we're already into tornado season. This is the earliest I can ever remember hearing it. But they say Saturday could be bad. Okay? And if it could happen on Saturday, it could happen on Tuesday, Thursday, or Monday, or Wednesday also. So keep that in mind. Okay? And active shooter, y'all know all the drill for that too, right? What you do for this room. So, okay. Any questions on any of those? Okay. Wow. Record getting through that. Thank you for both having been here before. Okay. I think we can get started on actually linear algebra then. Okay. Like I said, there are no PowerPoints for this book, or at least the edition I have, 7th edition. I'm going to see what's wrong. I should have an 8th edition. I don't know where it is and why I don't have it. I think I do. I may have just picked up the wrong book, but there's no difference in them to speak of. All right. Chapter 1, very short chapter. 3 sections, that's all there is. Okay? And a lot of this we're not even going to hash about too much because I think you're familiar with it already. Section 1.1 is an introduction to systems of linear equations. Okay? Like I said, you've had this before. So I don't see any reason to go into gory detail about it, but just as a review, here's one example of an equation, a linear equation. A1x plus, I'm trying to use the same symbols they do, A2y is equal to B1. No, is equal to B. They don't even put B1. Okay. Now, sounds like a dumb question. Why is that a linear equation? I claimed that it was. Is it? What makes that a linear equation? Any ideas? Key word here starts with E. What are your exponents in that equation? 1. That's what makes this equation a linear equation. Okay. What you have to do is find the variable. The variables is your x and your y. The a's and the b's are constants. Okay? So, find the variable. Those variables only have exponents of 1. And of course, if the exponent of 1, you don't write anything. But if this was a squared, or this was to a 1/2, or this was to a -3, that's not a linear equation. Okay? The exponent, the only exponent you can have for your variable is 1. And usually if it's 1, you don't even write that. That's what makes it a linear equation. This a is a constant, that a is a constant, probably a different constant, or the same, it doesn't matter. That's a constant. They can be positive, negative, fraction, decimal, rational, irrational, any real number at all. Okay? Those are constants. Okay? Your variables, however, the exponents can only be 1. They can't be any old integer, can't be any old rational number, can't be anything other than the number 1. That's what makes a linear equation. Now this is a linear equation in 2 variables. In 3 variables, it would look very similar. A sub 1x plus a sub 2y plus a sub 3z is equal to b. Okay? Again, a linear equation, the number of variables, the number of constants, that doesn't matter. All that matters is the exponents for the variables have to be a linear equation. Now, what if that b was a perfect square? Does that keep it from being a linear equation? No, because it's just a constant. It just happens to be a perfect square constant. Doesn't matter. Okay? That would be 3 variables, x, y, and z. Okay? Now, if you did systems of linear equations before, I bet you stayed with 2 equations, 2 unknowns, may have gotten up to 3 equations, 3 unknowns. But in this course, we're going to go to n variables. As many variables as you want to have. It has to be a finite number, but it does have to be here. So here is a linear equation in n variables. I'm going to start over here. So what if you had n variables? We'll call it x1, x2, x3, ... up to and including x sub n. We have n variables. So a linear equation in those n variables, now notice we didn't use x, y, and z now because we don't know how big n is, so we just use subscripts here too. A1 x1 plus A2 x2 plus A3 x sub 3 plus A4 x sub 4, I wrote more than a minute to, plus ... up to A sub n x sub n is equal to b. Okay? That is a linear equation in n variables. Okay? Now, it doesn't matter what you call those coefficients. It really doesn't matter what you call the variables. They don't have to have the same subscripts, but most of the time they do, just so you can identify and say, this is a variable that goes with that. This is a coefficient that goes with that variable. Okay? So this is a linear equation with n variables. Okay? Linear because none of the variables has an exponent other than 1. Okay? These are called coefficients, as I've been calling. This is called the constant term. Okay, because it can't have a variable in it. It's a constant term. Any real number, the coefficients, any real number. And we usually call the first one, a sub 1, the leading coefficient, because we call a sub 1, x sub 1, the leading term. This is just nomenclature here. Now, I hope you remember the definition of term, right? A term is any combination of numbers and variables and operations, especially multiplication and division, as long as the variable is not in the denominator. It has to be in the numerator because the coefficient has to be 1. Okay? But this could be x1 divided by a1 or something like that. That would be fine. But any combination of numbers and or variables separated by plus or minus signs. That's what designates a term. So to have a plus or minus in it, then that keeps it now. With one exception. If this was a1 plus a2 times x1, then that would be one term because this is just a constant. Okay. So it's but that's what we call the leading coefficient, leading term. Now, that's going to be important for us later. It doesn't seem very important now, but we want that leading coefficient a lot of times when we're doing matrix reduction to be a 1. And that's what our goal is going to be. So that's the reason they point that out. And x sub 1 then, of course, is the leading variable. Okay. All right. Now, this is all very, very simple stuff. You tell me whether or not these are linear equations. 3x plus 2y equals 7. Yay or nay? Yeah, okay. How about this one? 1/2 x plus y minus pi z is equal to the square root of 2. Is that a linear equation? Say again? Yes. It doesn't matter whether you got fractions, decimals, rational, irrational. It doesn't matter on the coefficients at all. Only thing that matters is the degree of the exponent, and that can only be 1. How about this? Sine pi times x1 minus 4x2 is equal to e squared. Linear or not? Why not? Yeah, but e is a number. If that was e to the x, you'd be absolutely right. That would not be linear. But e squared, e is just a number. It's a base. The natural base of our number system, 2.7 Bob is the base e. Okay? So that's just a number. Minus 4 is just a number. Sine pi is just a number. If that had been sine x2 or pi x2, no. That's not a linear equation because that would, see, there's no variable in here. That's just a number. Sine pi is 0. Okay, so not much of a number, but it is. Okay. How about this one? Linear or not? Okay. And, okay. I guess I sort of left off maybe part of the definition. Each term, they didn't say it either, I don't believe. But each term, the degree, okay. I said the exponent for each variable has to be 1. Really, the better way to say that, the degree of each term has to be 1. And this one, because this is 1 and that's 1, the degree of that term is 2. Remember, add your thing. So you can't have a product with two variables. That is not linear. Okay? 3y, that would be fine. 7x, that would be fine. But xy is not fine because that is not a linear thing. If you plotted that, which I know you want to do, it's curved like that. Remember, xy is a curve. It's not a linear function. Okay. This is a linear term, and that's just a constant. No problem there. This is not linear. Okay. So it's not just the exponent. I guess I overstated that. How about this one? E to the x minus 2y is equal to 4. Linear or not? Meaning, yes, it is linear. Okay. This certainly.
Wait. E to the x.
Yeah, if that would have been e to the 4, that would be linear. E to the minus 3, that would be linear. But e to the x, e to the x is like this. It's not linear. Okay? Doesn't graph as a straight line. That graphs as a straight line. That literally graphs as a straight line. This is not. So it's not linear. Okay. The variable cannot be your exponent, or in other words, your exponent can't be a variable. It has to be the number 1. How about this one? Sine x1 plus 2x2 minus 3x3 is equal to 0. Linear or nonlinear? Say again? Okay. You said linear? Okay. This is certainly a linear function, 2x cubed minus 3x. 3. Sine x, not linear, because that your variable is not, if this had been sine pi x, that would be linear. The sine of x, this is now the argument for the trig function, and that's not linear. Okay, so now, what do we mean by a solution of a linear equation? All these are linear equations. What would be a solution for that linear equation? Not particularly an easy thing to do, but just in general, don't give me actual numbers. What would be a solution for that? Okay, you're right at it. Is any ordered pair, because there's two of these, any ordered pair of values for x and y that makes that equation true? That's the solution. I'll just give you one. 0, 7 halves, 3 1/2, right? That will work, won't it? Or 7/3, 0. That would work. Okay. Any ordered pair, because you have two variables here, that makes that true. Okay. That would be a solution. Not a unique solution. There's an infinite number of those solutions. In fact, this graph has a straight line, okay, with a negative slope, okay? Not like that, nothing like that. Any point on that line is a solution for that equation. What would be a solution for this one? I'm not looking for a specific number here, but just tell me in general what would be a solution for that. This?
How would you have 3?
Yes, you have 3 variables, so you can have an ordered triplet, because you have to have some value for x, some value for y, and some value for z. I can give you a real easy one. 0√2, okay? That will work, won't it? But that's just one of an infinite number. Well, guess what? If you combine all those together, you get a straight line through space. This will be a straight line in a plane. This will be a straight line in a space because all of the coefficients here are, all the exponents here are 1. That is going to define a line, but this will be in space, free space.
When we use the z variable, is that for like vectors?
Okay, if there's your x-axis, here's your y-axis, there would be the z-axis. Free space, I can illustrate that way. For space, I have no clue. Okay, but you can have in space, remember? And in linear algebra, you can do that. But all of the exponents of the variables have to be, they also have to be linear forms. This again would be something in 2 space. Okay? And because we know sine pi is always 0, then this would be, actually this has only one solution. These other have an infinite number, this will only have one. Because that's 0, this is not, it is a linear equation, but it only has one solution to it. And that would be e squared over 4. So that's not very good. This is not a linear equation, so let's not even fiddle with that. All 3 of these are not linear equations. But typically, a solution for a linear equation is a set of values for each of the variables that makes that equation true. Okay? So a solution of a linear equation in n variables is a sequence of n real numbers, and they call it S1, S2, S3 up to Sn, that satisfies the equation when you substitute those values in. Okay? So let's do a real simple one of those. Oh, we are. Shucks. We're just beginning to have fun, weren't we? We're always having fun. All right, we will... Wow, that really went by fast. I guess I talked too much to begin with. We will start right there next time. All right. We didn't really get, I don't think we got far enough to have any homework exercises. Let me just see. Maybe we did. Let me see. Yes, you can do any of the odds 1 through 5. And by the way, this book does have calcchat.com. I was surprised it wasn't on the cover, but it does. It does have that. calcchat.com for worked out solutions. The odds are in the back of the book, but they're also at calcchat.com. We'll pick up the rest of those next time. So you can do any of the odds 1 through 5. Not very many. Good deal. Any questions?